My name is Wei Zhang. I'm Associate Professor in the Department of Civil and Environmental Engineering. My research group majorly is working on how the coastal nature hazard interact with different kinds of civil infrastructures. Every time we have a natural hazard affect the coastal community, our civil infrastructures, including bridges, buildings, or power infrastructures, gonna suffer a lot. We want to try to make sure if we better understand the environmental parameters interact with our civil infrastructures, we can better predict analysis, and then we can make our civil infrastructures a little bit more resilient, robust, and more safe. So then next time when there's a storm, we can be better prepared, make sure we have less disruptions. My work naturally is a little bit interdisciplinary work. We work with the power industry, utility and companies, Eversource. I'm part of Eversource Energy Center as well. We also worked for National Science Foundation. So I have one project is about fatigue prognosis, is about the bridges that continue to suffer with a lot of dynamic loads from wind, waves, and also have the corrosion issues for crack development. So one research we are doing for this small wind tunnel, we are trying to do wind energy harvesting. So energy is a big problem for the 21st century. So there's a lot of efforts trying to find a new renewable energy. The work we are doing right now is we are based on the failure of the first Tacoma Narrows Bridge. The bridge was failed and led to the future development and the improvement of bridge aerodynamics. We're trying to use this bridge section type, which is much more vulnerable to low wind-induced vibrations. And use this, we can use some other devices to make it to vibrate more violently. So therefore, we will be able to extract more energy from the wind field compared with the traditional wind turbines.
My research project is about the wind's influence on the low-rise wood building. I can use the data from the experiments to do the finite element simulation. So I can take the experiment and also take my finite element model.
I have 7 Ph.D. students and also 2 undergrad students working with me. My approach of working with them is I try to start with the perspective that I was an engineer before, and right now I work as a professor. I try to link the academia world and the real professional engineer world perfectly for the students. If in the future want to be an engineer, you have the work to do for engineer. If in the future you want to work for the academia, we have those kind of research efforts can push you to the limit that you can reach.